Welcome to this statistics tutorial on coding the mean. First of all, I'd like to have a go at the starter problem yourself, but without the aid of a calculator please. I'd like to pause the video now and give that a go. An efficient approach we could use here is to code the data. For convenience, I've called the original distribution set X and I'm going to create a new distribution set Y. What I'd like to do is divide all of my data in set X by 1000, because you can see they all end in 3 zeros, and then you can probably see that I'm going to get answers that are approximately 500. So I might minus 500 as well, and then I'll have numbers that are quite near to 0, which hopefully will mean they're quite easy to add up. So using that coding rule, I'm going to create some new data here. That's going to be set Y. So if you look at the number here, we're going to divide by 1000, get 460, take off 500, so we're on minus 40. Then we're going to divide 1000 there, take off 500, so we're on 75. Okay, and we do this for all of the data like so. So the ultimate objective is to work out X bar, the mean house price, but forget about that for now. It's much easier to work out Y bar, which we can do by first of all working out sigma Y. Now because of how we coded the data, this should be quite easy to do without a calculator. If we're going to add all of this up, it's really quite easy. Note that those two together give 100. I can put that in there. Note that these two together give 0, so that's quite easy to add up. These two together give 10, so let's add 10 there. And finally the last two collectively give 50, so the sigma Y, all of the Y data added up, is 160. So we can now work out the mean for the Y data, which is sigma Y, which is 160, divided by how many we have, which is still 8, giving 20. Now we need to decode. So if we look at how we coded the data, we divided everything by 1000 and then subtracted 500. Now think what effect that will have on the mean. If everything's got 1000 times smaller, you'd expect the mean to get 1000 times smaller. And if you subtract 500 off everything, you'd expect the mean to go down by 500 as well. So we need to undo that. And if you do opposite operations, we need to undo, first of all, that we minused 500. So if we're trying to work out what X bar is, we take what Y bar is and we need to add 500 first. And because we divided by 1000, we then need to times there by 1000. Now if you struggle to follow those inverse operations, don't worry, I'm going to teach you another method. And that is to look at the original coding formula and write it out again, but this time we're just going to replace Y with Y bar and X with X bar. And all we can do is just use algebra now to rearrange this equation to get X bar the subject. So one thing we can do is multiply both sides by 1000. So we've got 500 there, times by a further 1000, so add 3 zeros. So now we've got the X bar, it's 1000 Y bar plus 500 1000, which is actually the same thing that we got before. The only difference was that 1000 was factorized out there. So that is telling us how we decode. So therefore we can actually work out x bar, which is 1000 times what y bar was, plus 500,000. So the mean house price there will be 520,000. Now viewers, I've got some problems for you to try. So if you'd like to have a go at this problem, I'll just zoom into that so that you can all see it. If you'd like to pause the video, and once you've done that, you could perhaps have a go at this one, slightly more difficult. If you'd like to pause the video, and now I'm going to show you the solution to those. So the first question, 305, and the extension question there is 0.5. If you perhaps like to have a go at these problems, I'll just zoom into that so you can see. And another problem here. And we've got solutions to the problems there. And you could give this one a go. And this one. And we've got some solutions to the problems there. Example 1. So here we have a grouped frequency distribution. Consequently, it's impossible to actually work out the mean, we can only estimate it. For example, these 12 employees here, it's unclear how much they actually earn. So our best guess, if you like, is to assume that they all earn £5,000. We go for the midpoint. And we need to do that with all of the classes, all of the groups. So the midpoint there is 12,500. The midpoint here is 17,500, etc. We just need to be careful because the group at the bottom is wider. So when we get to here, the class, the group is much wider. The midpoint there is of course 40,000. Normally we would now work out the fx column, so we do that times that plus that times that, etc. But now we're going to do something slightly different. The numbers there you can see would be quite large, so we're going to use this coding formula to come up with something slightly different. So we won't be using these as our midpoints. Following the coding formula, what we need to do here is 5,000, subtract the 5,000 from the coding formula, gives 0, then divide by 2,500 is of course just 0. And then next we've got the 12,500 there, subtract the 5,000 there is 7,500, divide by the 2,500 on the bottom, that gives us 3. And we keep coding as like that, and we get the following. Now these numbers are much easier to deal with. So forget about that column now. We're not going to work out f of x, we're going to work out f of capital X instead, the coded version, as follows. So sigma f of capital X will be, for example, 12 times 0 plus 63 times 3, etc. Perhaps I'll just do the last one as well, which will be 4 times 14. And if you work that out on your calculator, you get 624. So that's all of the salaries added together, well, the coded salaries added together, I should say, and we now need to divide by how many there are. Well, if you total this column up here, you'll find that you get 140. So we're now in a position to work out the coded mean, which is all of the coded salaries added together divided by how many there are. We get there 156 divided by 35 in a simplified form. Finally, we just decode. To do that, a good strategy is just to write out the coding formula, but put a bar over the top, and we can now just rearrange this formula, making x bar the subject. And if you do that, you end up with x bar equaling the following. And this will be how we decode. So if we drop in what we know capital X bar to be the coded mean, it's this, and if we add 5,000 here and use our calculators, we get the following estimate for the mean to 3 significant figures. I think quoting anything above 3 significant figures is a little bit misleading, given that this was indeed grouped data.